Hello viewers and dear students. In this video, I'll solve the questions on Poisson distribution from section 4.8 Check Your Progress, which is based on the student support material uploaded by CBSE. The 12th question is also on Poisson distribution, but it is slightly lengthy. So I have kept the 12th question to be solved at the last. We'll start from the 13th one. A statistician records the number of trucks approaching a particular intersection to analyze the flow of traffic. He observes that on an average 1.6 trucks approach the intersection every minute. Assuming that the number of trucks approaching the intersection follow a Poisson distribution model, what is the probability that 3 or more trucks will approach the intersection within a minute? So here it is given a statistician, he records the number of trucks approaching a particular intersection, and it is observed that on an average 1.6 trucks approach every minute. And they have already said we have to assume number of trucks approaching the intersection follows a Poisson distribution model. We have to find the probability that 3 or more trucks will approach the intersection within a minute. So this is quite simple. So in this question it is given average 1.6 trucks approach the intersection every minute. And here we are also taking x denote the number of trucks approaching the intersection every minute. So here it is given lambda is equal to 1.6 trucks per minute. Then the probability mass function, it is given by probability of x is equal to k, it is equal to lambda power k e raised to minus lambda by k factorial. Here lambda is 1.6, so it is 1.6 raised to k into e raised to minus 1.6 upon k factorial. Now we need to find the probability that 3 or more trucks will approach the intersection within a minute. So we have to find probability of x greater than or equal to 3. Now this probability of x greater than or equal to 3, it is 1 minus probability of x less than 3, or it is 1 minus probability of x is equal to 0, 1, 2. So this we can easily find by substituting k as 0, 1 and 2 in each of these, and then when we simplify we will be able to find the probability that 3 or more trucks will approach the intersection within a minute. So this is equal to 1 minus probability of x is equal to 0 is 1.6 raised to 0 e raised to minus 1.6 upon 0 factorial plus 1.6 raised to 1 into e raised to minus 1.6 upon 1 factorial plus 1.6 the whole square into e raised to minus 1.6 upon 2 factorial. Or here e raised to minus 1.6 is common, it can be taken outside, and here we have 1 plus 1.6 plus 1.6 the whole square by 2 factorial, which is 2. Now when we simplify we get this is equal to e raised to minus 1.6, it is 0.202 into 3.88. Or this is equal to 1 minus 0.784. This is 0.216. So the probability that 3 or more trucks will approach the intersection within a minute is 0.216. Next question, a computer disk manufacturer tests disk quality on random basis before approving it. The approval is based on the number of errors in a test area on each disk and follows Poisson distribution with lambda is equal to 0.2. What is the percentage of test areas having 2 or a smaller number of errors? So here it is given a computer disk manufacturer, he tests the quality of the disk. for errors, and it is given the number of errors in a test area. It follows Poisson distribution with lambda is equal to 0.2. Now we have to find the percentage of test areas having 2 or smaller number of errors. So here let the random variable x denote the number of errors, and it is already given lambda is equal to 0.2. So we can write the probability mass function for this random variable x. So probability of x is equal to k. It is given by lambda raised to k e raised to minus lambda upon k factorial. Now it is asked what is the percentage of test areas having 2 or smaller number of errors. So we have to find probability of x less than or equal to 2. So probability of x less than or equal to 2, it is 0.2. That is probability of x is equal to 0, 1 and 2. So probability of x equal to 0 is 0.2 whole raised to 0 into e raised to minus 0.2 by 0 factorial plus 0.2 raised to 1 into e raised to minus 0.2 by 1 factorial plus 0.2 whole square e raised to minus 0.2 by 2 factorial. Now e raised to minus 0.2 is common, and e raised to minus 0.2 it is equal to 0.819. This e, it is nothing but it is the Euler's constant, so it is 2.718 the whole raised to minus 0.2. This is equal to 0.819. So this is equal to e raised to minus 0.2, it can be taken outside, and the value is 0.819 into 1 plus 0.2 plus 0.04 by 2, or this is equal to 0.819 into 1.22, or it is equal to approximately equal to 0.999. So the percentage of test areas having 2 or more smaller number of errors, it is equal to 99.9%. Next question, very easy question. In a Poisson distribution, if mean is 2, what is the variance? We know that in a Poisson distribution the mean and variance are equal. So given expectation of x is equal to 2, so in Poisson distribution expectation of x equal to variance of x equal to 2. Since x follows Poisson distribution with lambda as the parameter, here lambda is equal to mu. Here lambda is equal to 2. Next question, it is given that 3% defective electric bulb are manufactured by a company. Using Poisson distribution, find the probability of 100 bulbs will contain no defective bulbs. So it is given a company which manufactures electric bulbs. Of every 100 bulbs, we have 3 defective bulbs. So using Poisson distribution, we have to find the probability that in 100 bulbs, there will be no defective bulbs. Here in the question itself, it is given use e raised to minus 3 is equal to 0.05. So let us take, let x denote the number of defective bulbs. And here it is given lambda is equal to 3. Since it is given 3% defective electric bulbs, so the mean is in every 100 electric bulbs there will be 3 defective. So lambda equal to 3 defective bulbs in every 100 bulbs. Now we need to find the probability of 100 bulbs will contain no defective bulbs. That is, we have to find probability of x is equal to 0. Now, the probability mass function for this Poisson distribution, it is given by probability of x is equal to k. It is equal to lambda raised to k. Lambda is 3, so it is 3 raised to k e raised to minus lambda, that is minus 3 by k factorial. Now, we need to find probability of x is equal to 0. So, probability of x is equal to 0, it is very easy. It is 3 raised to 0 into e raised to minus 3 by 0 factorial. In the question itself, it is given use e raised to minus 3 as 0.05. So, this is equal to 0.05. So, the probability that of 100 bulbs will contain no defective bulbs is 0.05. The next question, the mortality rate for a certain disease is 0.007. Using Poisson distribution, calculate the probability for 2 deaths in a group of 400 people. So, here it is given the mortality rate for a certain disease is 0.007. 0.007, it is 7 by 1000. That is, in every 1000 people, the mortality rate is 7. Now, we have to find probability of 2 deaths in a group of 400 people. So, here we have to take the width as 400 by 1000 to find this probability. Probability for 2 deaths in a group of 400 people. So, let us take, let x denote the number of deaths in 400 people. Given lambda equal to 7 deaths in 1000 people, we need to find the deaths in 400 people. So, the width W will be 400 upon 1000, or we can write it as 4 by 10. Now, expectation of x, it will be W lambda. So, it is 4 by 10 into 7, it is 2.8. So, the mean for this distribution, the deaths in 400 people, it is 2.8. Now, we can write the probability mass function. Probability of x is equal to k. It is equal to lambda raised to k e raised to minus lambda upon k factorial. Now, we need to calculate the probability for 2 deaths in a group of 400 people. So, we need to find probability of x is equal to 2. So, probability of x is equal to 2, we just have to substitute k as 2. So, it is equal to 2.8 the whole square into e raised to, e is the Euler's constant, so it is 2.718 the whole raised to minus 2.8 upon 2 factorial. Since in class 12 syllabus using log tables is there, we can also use log tables to find the value of this expression. So, this is equal to this 2.718 whole raised to minus 2.8. So, it is equal to 0.06 into 3.92, or it is equal to 0.235. So, this is the probability of 2 deaths in a group of 400 people. The next question, an ice cream parlor receives a customer at an average rate of 4 per minute. If the number of customers received by the parlor follows a Poisson distribution, what is the approximate probability that 16 customers will be coming to the parlor in a particular 4-minute period on a given day? So, here it is given an ice cream parlor receives customer at an average rate of 4 per minute. That is, every minute it receives 4 customers. And it is also given number of customers received by the parlor follows Poisson distribution. We have to calculate the probability that 16 customers will be coming to the parlor in a particular 4-minute period on a day. So here the average rate is given for 1 minute, but we are asked to calculate for a period of 4 minutes on a given day. So let X denote the number of customers in a 4-minute period. And here we need to find, but it is given lambda is 4 per minute. Given lambda is equal to 4 customers per minute. So the width W is equal to, we need to find for 4-minute period. So W is equal to 4. So expectation of X is equal to W into lambda. So it is 4 into 4, 16. Now the probability mass function, probability of X is equal to K, it is given by lambda raised to K e raised to minus lambda upon K factorial. So for our random variable X, lambda is 16. So probability of X is equal to K is given by this probability mass function. Now we need to find probability that 16 customers will be coming to the parlor. So we need to find probability of X is equal to 16. So in place of K we have to put 16. So it is 16 raised to K. E raised to E is 2.718, that is the Euler's constant, 2.718. The whole raised to minus 16 upon 16 factorial. So it is a huge quantity. We can use log tables since log tables are there in the syllabus. When we calculate and simplify, we get this as, this is equal to 0.099. The 12th question, it is not difficult, it is slightly lengthy. Anyway, we'll see how to do this. A customer care company receives an average of 4.5 calls every 5 minutes. If each customer executive can handle one of these calls over the 5-minute period, but if an executive is not available to take the call, then the call is put on hold. Assuming that the calls received by the customer care company follows a Poisson distribution, what is the minimum number of customer executives needed on duty so that calls received are placed on hold for at most 10% of the time? So here it is given, a customer care company receives an average of 4.5 calls every 5 minutes and each customer executive can handle one of these calls over a 5-minute period. On the other hand, if the executive is not available, the call is put on hold. And we are assuming that the calls received follows a Poisson distribution. We have to find the minimum number of customer executives needed on duty so that the calls received are placed on hold for at most 10% of the time. That means the calls should be answered 90% of the time. So here let X denote the number of calls in every 5 minutes. So lambda is 4.5 calls per 5 minutes. Here it is given average of 4.5 calls every 5 minutes. Now we need to find the minimum number of customer executives or the minimum number of times the calls should be answered so that the calls received are placed on hold at most 10% of the time. That is, it should be answered for 90% of the time. So we need to find probability of X less than or equal to K. This should be greater than 90% of the time or 0.9. So we need to find the value of K for which probability of X less than or equal to K is greater than 0.9. Now the probability mass function, it is given by probability of X is equal to K is equal to 4.5 lambda raised to K e raised to minus lambda upon K factorial, or it is equal to e raised to minus 4.5. I calculated it as 0.011. So 0.011 into 4.5 the whole raised to k upon k factorial. Now let us find each of these. That is, we have to put k is equal to 0, k is equal to 1, 2, 3 up to etc. until we get probability of x less than or equal to k is greater than or equal to 0.9. So now that value of k will be the number of customer executives. So let us have k here, and here probability of x equal to k, and here probability of x less than or equal to k. Now first let us take for k is equal to 0. Probability of x is equal to 0 will be, in place of k we have to substitute 0. So it is 0.011 into 4.5 raised to 0 divided by 0 factorial. So it is 0.011 into 1. So it is equal to 0.011. Then when k is equal to 1, then probability of x is equal to 1 is given by 0.011 into 4.5 raised to 1 upon 1 factorial. So it is equal to 0.011 into 4.5, or it is equal to 0.05. Now probability of x less than or equal to 1 will be probability of x is equal to 0 plus x is equal to 1. So it is 0.06. And now let us take for k is equal to 2. So probability of x is equal to 2 will be, in place of k we have to substitute 2. So it is 0.011 into 4.5 the whole square upon 2 factorial. Now this is approximately equal to 0.11. Now probability of x less than or equal to 2 will be the sum of these three. So it is 0.17. Then for k is equal to 3, probability of x is equal to 3, it will be 0.011 into 4.5 the whole cube upon 3 factorial. Now this we can calculate it as the previous one into 4.5 by 3. If we do that, we will get the value over here. So probability of x is equal to 3, it is approximately equal to 0.17. So now probability of x less than or equal to 3, it will be the sum of all these. So it is 0.34. Then the next one, k is equal to 4, probability of k is equal to 4 is 0.011 into 4.5 the whole raised to 4 upon 4 factorial. Again, to find this, we can take this value into 4.5 by 4, because already 4.5 the whole cube by 3 factorial into 0.011 is this value. So into 4.5 by 4 if we calculate, we will get this value. So this is equal to, so probability of x is equal to 4, it is equal to 0.19. Now probability of x less than or equal to 4 will be the sum of all these, or it is 0.53. Now the next value, we need to know whether this value is greater than or equal to 0.9 or not. We need to find for which value of k this value is greater than or equal to 0.9. Now the next one is probability of x is equal to 5. So 0.011 into 4.5 the whole raised to 5 upon 5 factorial. When we simplify, we get this is approximately equal to 0.17. Now probability of x less than or equal to 5 will be the sum of all these, or it is equal to 0.70. Then when k is equal to 6, probability of x is equal to 6. It will be 0.011 into 4.5 the whole raised to 6 by 6 factorial. Again, this can be calculated as this value 0.17 into 4.5 by 6. So it is approximately equal to 0.13. Now probability of x less than or equal to 6 will be the sum of all the probabilities. So it is 0.83. So we are nearing this 0.9. Now when k is equal to 7, probability of x is equal to 7, 0.011 into 4.5 the whole raised to 7 by 7 factorial. This is nothing but into 4.5 by 7. So it is 0.13 into 4.5 by 7. It can be calculated that way also. This is approximately equal to 0.08. So when probability of x less than or equal to 7 will be the sum of all these probabilities, or it is 0.83 plus 0.08. This is 0.91. So we got 0.91. So probability of x less than or equal to 7, this is greater than or equal to 0.9. Therefore, probability of x less than or equal to 7 is greater than or equal to 0.9. So the number of customer executives needed are 7. Therefore, answer equal to 7. Therefore, the required executives are 7 executives. I hope this video was useful for you. Thank you for watching.